Okay, so let's have a look at this example with two cars. We've got car A and car B. We can represent their velocity with vectors. So car A is travelling at 30 kilometers per hour south, so you can draw a vector south, maybe 30 kilometers per hour. And car B is travelling at 40 kilometers per hour due west. So let's have a nice vector west, 40 kilometers per hour, west. Now, if I want to work out how car B appears to someone travelling in car A, or how car B is travelling relative to car A, then basically what I have to do is say that the velocity of B relative to A is B minus A. So B minus A is B minus A, which is this, and so the resultant vector will be like this. Now if I know that B is 40 kilometers per hour, I'll leave the units out, and this is 30. 3 Esther 4 Esther, that must be 50 kilometers per hour according to simple trigonometry or geometry. So it's 50 kilometers per hour, and if I want to know the direction, that angle there, well, I know from trigonometry that tan theta equals the opposite over the adjacent. In this case, it's going to equal 30 over 40. So theta is going to equal the inverse tan of 0.75. Plug that into your calculator and you'll get an answer that says it's west 37 degrees north. You'll find that theta equals 37 degrees. So ultimate answer is 50 kilometers per hour west 37 degrees north. Okay, too easy. Now let's have a look at let's do the opposite. Let's look at how car A appears to car B. So let's look at A relative to B. So A relative to B would be A minus B. Okay, A being 30 kilometers per hour, B being 40, and so we're going to get the same sort of triangle but a different direction. So this is going to be 50 kilometers per hour. This direction theta, remember that inverse tan, or that tan theta equals opposite over adjacent, which equals 40 over 30. So tan, the inverse tan of theta, what am I doing? Theta equals the inverse tan of 4 over 3. Let's have a 1 1/3. So that's going to equal 53 degrees. So we know our result is going to be 50 kilometers per hour south, 53 degrees east. How cool is that? So we've just followed our rule here, which is that when you are trying to find the velocity of A relative to B, it's a minus b in vectors. Velocity of b relative to a is b minus a in vectors. Okay, tricky.